Hey everybody, Mr. Simons here. We are now going to start looking at solving one-step equations. Now, many of you have done this in the past. I believe they usually start teaching you how to do this when you are in 6th grade. So this shouldn't be too much of a reach for most of you, but we're going to definitely go in a little deeper and do some problems that are slightly more difficult. And this is kind of the building block for that. And there's a couple important concepts in here that we want to talk about. So pretty much, before I start showing you these, I just want to kind of explain something that I think gets lost a lot of times. If I have a teeter-totter, right? Or seesaw, whatever you want to call it. And, I put my fulcrum there. Pretty much, if I have if I have one person over here, and I have another person of the equal weight, that's about the same distance from the fulcrum away on the other side, the seesaw will be balanced, right? But what happens is, supposing I decide to add another person over here, then this part of the seesaw starts to go down. So in order to balance it out, I have to do the same thing to the other side, right? So I go like this. And then maybe this side says, well, this guy is going to get off the seesaw right here. Well, in order to prevent this side from now going up and this side going down, I have to do the same adjustment over here. So this is a really huge concept in algebra, and it has to deal with balanced equations. It has to deal with what you can do whatever you want to one side of an equation as long as you do the exact same thing to the other side. All right, and that's one of the couple of things I'm going to really try to hammer home throughout this whole unit with you guys. But if you can just kind of keep this visual in your head, it should make some sense to you, and you'll start to get the hang of it in no time. All right, so we're going to start at looking at equations that you have to solve by doing some addition to them. So with most of these, I'm just going to rewrite them because they're a little easier. I am showing you how to do all of these in the vertical method. Now, really quick, and I'll show you the horizontal method in a moment after I solve this first one here. But just so you know, I don't really mess around with the horizontal method that much anymore. That's actually how I learned it. But I think the vertical method, even though it uses more space and paper, is visually a lot easier to deal with, and it's easier to follow. So that's what I teach now. So what I always do is I always draw a little line, okay? And I just think it sets the tone for what you're doing. So if you've got c minus 22 equals 54, the whole goal in any equation is to get the variable by itself with a coefficient of 1. That's always the goal. Get the variable by itself with a coefficient of 1. So right now it has a coefficient of 1, but it's not by itself. It's sharing the left side with that negative 22. So I got to get rid of that. And so I'm going to get rid of it by adding it. And now think of the seesaw, right? So because I added 22 over here, I have to keep things balanced, so I got to do the same thing over there. And then what happens is this cancels out, and then you get 76 over here, and you get c equals 76. If you put 76 into that equation, 76 minus 22, and that boils down to 54. And you know that you've solved this correctly. Now, if I were going to teach you doing this horizontally, I would set it up the same way. I would go c minus 22 equals 54, and I'm not going to draw a fence. And then what I would do is I would say, okay, I'm going to go c minus 22, and then on the same side of the equation, I'm going to add 22. Okay? And then what I would do is I would have 54 over here, and then because I did it on the left side, I'd do it on the right side. And so you can see what I mean about it taking up less paper, but I don't think it's as easy to look at as this. And then you do the same thing. You realize that this all cancels out with each other, and you get c is equal to 76. So they get you the same place. Like I said, I prefer the vertical method, but I did learn the horizontal method All right, this is the horizontal method, and this is the vertical method. So I will be teaching from here on out pretty much exclusively doing the vertical method. All right, so now you try this. So pause the video, try the problem, and then come back. Okay, I'm assuming you've done this now. So let's rewrite this. J minus 87 equals -3. Set up your fence. Make the connection that J is in good shape, except we got to get rid of that -87. So we do the opposite of it. So add 87 to it. And then I am going to do the same thing over here. And then you wind up with J. And then remember, with your integer rules, you would just go 87 minus 3, which gives you 84. And then you take the sign of the number with the largest absolute value, and that would be this one right here. So it's a positive sign. So J equals 84. All right, let's do a subtraction one. I'm going to rewrite this. And most of you can do these in your head, and that's great, but I don't want you doing these in your head. I want you doing these on paper and getting used to the process, because when these things get hairy, you're going to definitely want to know how to set them up and how to start, okay? So again, the goal is to get this so that the variable is by itself and has a coefficient of 1. It's already got a coefficient of 1 in these cases, so it's not by itself, and it looks like 63 is being added to it. So what I want to do is subtract 63 from it. And remember that this does have a sign. It's just not shown, but its sign is positive. Okay? And remember, the sign of anything in an equation is always to the left of that term. It's always to the left. So because I subtracted 63 from there, I'm going to subtract it from here. All right, and then that cancels this out here, makes that 0. They call that the addition or subtraction property of 0, but I mean, it's kind of a common sense thing. If you want to get rid of something, you do the opposite of it, do the inverse of it, and then you're good. 79 minus 63 gives us 16. M equals 16. Plug 16 into this to confirm that you did it right. 63 plus 16 simplifies down to 79. That's what this is. They equal each other. Good times. All right. You try this one. All right. Let's see how you did. -12 equals P plus 16. Set up a fence. Our variable is on the other side, but that doesn't change anything. So this is plus 16, so we want to do the opposite. So I think I'm going to do some color coding here. So let's do minus 16, all right? Then that gives us P, because these cancel out. And then you have -12 and -16. So you can think of it as -12 minus 16, or you could think of it as -12 plus -16. That's how I like to think about it, because if the signs are the same, then you just add it up. You get 28, and then you keep the common sign, and the common sign is negative. And you have -28 is equal to P. Put it in our equation really quick. And at some point, you're going to just want to automatically always check your answers. And there is not a good mathematician alive who just gets an answer and says, oh, well, I know that's right because I got it. Because guess what? We make mistakes all the time. All right, so you get -12, and then this over here simplifies down to -12 as well. Okay, next example. There's two here. So this says solve by multiplying or dividing. So when they talk about solving by multiplying, and in this case that I'm showing you, I'm going to show you another case after we do a couple of these. But in this case, you're always multiplying usually the reciprocal of a fraction. All right, and this is a skill that really confuses a lot of people, and it's really not that confusing. It's actually pretty simple, but it just looks scary, and people tend to freak out because they're fractions. So step one, don't freak out because it's a fraction. It's really not that difficult. You got this. All right, so the thing is, there's nothing being added or subtracted, so I don't have to do anything with that. But my coefficient in front of my variable, which in this case is q, is not 1. So I need to get 2/3 to 1. Well, there's that cool rule we talked about, which is the inverse property of multiplication, right? Multiplicative inverse. So what you're going to do is you're going to take this and we're going to multiply this by whatever the inverse of 2/3 is, whatever the inverse of the coefficient on the variable that you're trying to solve for. And if it's negative, you have to make it negative. If it's positive, you leave it positive. So in this case, it's positive 2/3. So the inverse of that is 3/2. And because this is our balanced equation, we're going to multiply the other side also by 3/2. Okay, so what happens here is if you did this the slow way and multiplied it out, you would do 3 times 2 is 6, and then 2 times 3 is 6, and 6 over 6 just equals 1. That's what we want. The way I look at it, though, is these cancel out and these cancel out. Okay, so same thing, you get to the same result. It's just I don't bother even doing anything with that because I know if I wrote it correctly and I'm multiplying it by the right thing, I know it has to go to 1. All right, and so on this side, you got 1 times 3 is 3, 2 times 2 is 4. I don't have to simplify it. Q equals 3/4. So 2/3 of 3/4 is 1/2, and that makes sense because if you break 3/4 into thirds, each third would be 1/4 because it's a third is just 3 equal parts that add up to the whole. Well, if the whole is 3/4, 1/4 plus 1/4 plus 1/4 is 3/4, and 2 of those gives you 1/2. So nice, we're happy. All right, next, let's look at this one right here. This 39 equals negative 3r. So what you do with these is just recognize the fact that in order to get this r by itself, you look at what's being done to it, and it is being multiplied by something already. So what we're going to do is we're going to do a good old switcheroo and do the opposite, and we're going to divide. And you divide by whatever the coefficient is to get it to be 1. So if it's negative 3, you divide by negative 3. And divide this side by negative 3. And then that will give you r is equal to negative 13. And then you just take your negative 13 and plug it in your equation. Negative 3 times negative 13 gives you 39. Okay, so now here's a couple. I want you to try these, all right? All right, I'm assuming you've tried these now. So we have negative 1/4 equals 2/3 b. We'll do this side first, okay? Make our little fence. 2/3 is our coefficient, so we're going to multiply everything by 3/2. And this is actually a lot like our example problem. So these cancel, those cancel, and getting your coefficient to be 1, which is what we want. Then you have 3 times 1, which is 3. 2 times 4 on the denominator, which is 8. And then you have a negative times a positive, so that gives you a negative. It doesn't matter if you write a fraction as negative 3 over 8 or negative 3/8 or 3 over negative 8. It's all the same thing because if you think about it, it's a division problem. The whole point is that you have only one negative sign in there. All right, and then you have your answer, negative 3/8. If I plug that back in there, 2/3 times negative 3/8. My 3's cancel. You get negative 2/8, which is the equivalent of negative 1/4. So checks out. All right, this one. So 12t, I'll make it a little bigger, equals negative 132. T is being multiplied by 12. I want to get that to be 1, so I'm going to do the opposite of multiplying by 12 and divide by 12 instead. So then that gives you t is equal to, well, you do 132 divided by 12, gives you 11, and you have a negative divided by positive, which gives you a negative. And if you put negative 11 into that equation for t, that gives you negative 132, which is our number. Okay, we got, I think, two more 2 more problems to do. So we're going to do number 40 as our example, and then you're going to try 39 on your own. So c over 4 is equal to negative 9/8. Now, I could tell you that you could rewrite this problem like this, and then just solve it the way we just talked about, where you multiply everything by 4 over 1, just do the reciprocal. But I think the idea is for us to just recognize something in some of these cases where there's just a slightly easier way to do it. If you look at C and you think about what's being done to it, it's being divided by 4. And we've talked about just do the opposite to it. Well, if it's being divided by 4, just multiply it by 4. And so I'll multiply this side by 4 and I multiply this side by 4, which pretty much gets you exactly where you were. Okay? So your 4s are going to cancel out. Sorry, I'm trying to stifle a sneeze right now. And you get C, and then you have negative 9 times 4 divided by 8. Let's use cancellation, all right? 4 goes into 8 2 times. It goes into itself 1 time. So 9 times 1 is 9, and then 2 is left by itself on the bottom, and then you have a negative times a positive, which is a negative. So you have negative 9/2 for your answer. And basically, if you have negative 9/2 over 4, that's the same thing as negative 9/2 divided by 4. Keep, change, flip. All right. There you go. And then that gives you negative 9/8. Okay. Keep, change, flip is how you divide with fractions. All right. So recalling a lot of wild skills that you haven't probably used or thought about in a while, but that's where we're at now. That's what we got to do. All right. Your job is to do number 39 now. So pause the video and then come back and see what I got for you. All right. Same deal. All right. Look at what's being done to n. It is being divided by 8. So we're going to do the opposite. And we're going to multiply that by 8 as well, because you want to balance your equation. So these cancel out, which is great. And then you get n, and then 4 goes into 8 2 times, goes into itself once. So 2 times 1 is 2 over 1, and then you have a negative times a positive, which is negative. And then let's simplify that. Anything over 1 is itself. So n equals negative 2, and negative 2/8 is the same as negative 1/4. They're equivalent expressions. Okay, last problem. We're going to do one word problem here and then cut you loose. All right, Allison is making a stained glass window. Her pattern requires that 1/5 of the glass should be blue. I'm thinking that 1/5 might be important. She has 288 square inches of blue glass. That's probably important too. If she intends to use all of her blue glass, how much glass will she need for the entire project? So if we're going to write an equation for this, right, they're asking us how much glass. So we want to figure out how much glass. Well, we know that 1/5 of it is blue. So let's use G. We know that 1/5 of it is blue. And we also know that that totals 288 square inches. So now you have an equation. You have 1/5 G equals 288. So look at this one. This isn't going to be an addition or subtraction one, right? Because you have a situation where the coefficient is not 1 and there's nothing being added or subtracted. So if it's not 1, we got to make it 1. And it's being multiplied by 1/5. So we're going to do the opposite, which is multiply by 5 over 1. Okay? We'll do the same thing over here, 5 over 1. So you get that nice cancellation there, which you want. And then you do 288 times 5. Well, 300 times 5 is 1,500. And 12 times 5 is 60. So we have 1,440 square inches of glass total is what she will need. All right, I hope this video was helpful to you. I always welcome your comments and everything. And good luck doing these problems.